Hello everyone, I am Sachin Gupta and today we are going to talk about HeapLens. It's an IDE integrated heap dump analysis extension with a declarative query language. So why HeapLens? You must have seen today that debugging memory leaks is becoming context switching. So the standalone analyzers that we have, they run in a separate window, they're disconnected from the source, and an engineer has to switch between analyzer, ID, browser, and terminal. They don't have any LLM explanation, so if an engineer wants to understand what the object is doing, why the memory is leaking, they don't have a way to understand that particular type of object in a plain simple language. As a result, our two-line config fix is taking around 20 minutes to figure out, and the tool is actually becoming our bottleneck. We'll talk about the architecture now. On the left hand side, whatever the user sees happens on the left hand side. You have the extension host, you have the web view UI, which has 10 interactive views, you have the d3.js for the chart. On the right hand side is the part which does the heavy lifting. You have a hpref parser, which has a zero copy map, the analysis engine, which prepare the CSR graphs, and they both communicate using the JSON RPC 2.2. What We'll move to the HeapQL. HeapQL is SQL-like query language. So if you see, we have four virtual table instances, class histogram, dominator tree, and leak suspect. It does have SQL features like select, where, group by, order by, join, subqueries. We don't support write join as of now. And if you see, we have the byte literal support as well. You have to do like you can provide 1 KB, 1 MB, 1 GB. You don't have to manually like do the byte conversions here. Now moving to the performance tab, uh, we did this for like baseline, post leak, and demo, which is 1.5 GB, 1.9 GB, and 14 GB. And if you see here, the result is like for 1.5 GB, the result is there in zero point 0.9 seconds. For post leak, which is 1.9 GB, the result is in 1.2 seconds. And for the 14 GB, we are able to get the result in 10.5 seconds. We'll move to the demo now, real quick. Now, if you see, I'm just uploading the demo file. So the moment I upload the demo file, you'll see the analysis is happening here. It says 14 GB and then the parsing has started and total it took around 8 seconds, 8.7 seconds, or you can say 9 seconds. The first tab that you see here is the overview tab, which tells you like what is your reachable heap, total heap, objects, classes. Copy incident report button basically gives you the basically copies all the information which is present on this particular tab. If I scroll down, you will see the heap composition and the top 10 by the retain sizes. We'll move to the histogram tab. If you see, this is where you will be able to see everything. And then if you want to filter something by the class name, for an example, array list, you'll be able to see. This is the array list, and then you will see here. This is what's happening here. When I click on the Y alive button, it will give me the GC path, super root, and then connection pool, then array list, and blah blah blah. Now we'll move to the Dominator tree. In the Dominator tree, if you see, we have tree and the flame graph option as well. And then, as we discussed, when we do Y live, you see the GC path is appearing here. If I want to understand more information like what it is doing, I'll click on this magnifying glass and I click on this explain this object. It will go to the LLM. It will try to understand what the subject is all about, and if it knows how to fix it, or if it knows like like the best way to fix it, it will give you an example as well. So you see, this gives you an example fix. This is what you can do, and after what you should be doing. This is the leaks aspect. We show the leaks aspect through object and by class as well. If you see, the object is here, and if I click on by class, I will be able to see it this way. And this filter, if you see, if I want to only understand like whatever is greater than 50%, I'll be able to see that as well. The moment I choose all, this appears. The waste tab tells you about like if you have any duplicate strings or anything, it gives you that particular information. If you have any empty collections, if you have any box primitives, it provides you this granular information for you to work on. Source tab will come to it later, but just to show you right now here, these are the classes that we have, but we'll explain this later. And the query tab also will come to it later. Now, compare tab, it requires two baselines, like basically two files for you to compare. The timeline, if you want to actually build your snapshot timeline, again, the minimum requirement is two files. Monitor tab, if you actually want to monitor something, like you deploy it, you give the you provide the port number, and then you connect it, and it will be able to tell you like how much Heap is being used, what is the max and the percentage. AI chat is something which I already asked this, like, can you please help me explain the heap dump? It told me that okay, 14.38 GB with over this many objects. And then I asked another question, can you prepare a query for me to understand? It actually prepared a query. The moment if I run it, I'll be able to see the data here. And whatever query that was executed here will reflect in the query tab as well. And here we are maintaining the history. As like this is the last query which was run. We'll see, okay, the query is changed. If I click on run, I'll be able to see the data. Now coming back to the source tab, the way it works is if you have the source code available and you're working on the same project, then the moment you click view source, it will open the source file. And if you actually want to fix it, you don't know how to fix it, and you can use this fix with AI button. The moment you click it, it will open another tab with the recommended fix. And then as a developer, you can always move it, like if you really want to use it. So this guy figured it out here, like connection.reset buffer is missing. And if I come here, I will be able to see here it is. Now I'll close this and we'll see if there is any tab that we have missed out. On the Dominator tab, we have, yeah, here it is. If you click here, since the source code is already available, this guy is able to give me the data. Yeah, fix. Thank you very much, guys. This is all about HeapLens. Please use this extension. It's open source. It's available on VS Code as well as other platforms. Whatever is supporting the V6 files, this VS Code is available this HeapLens is available everywhere. If you have any feedback or something, you can always open an issue on GitHub and leave us a feedback and a review comment. Thank you.